Welcome to Making Sense of Complexity, featuring conversations with complexity science practitioners and philosophers. Our goal is to share insights on how to make sense of our complex and uncertain world. Today, our guest is complexity science practitioner Daniel Friedman. Daniel is a researcher at the University of California, Davis in entomology and a co-organizer of both the Active Inference Lab and the Complexity Weekend Community of Practice. Let's begin. Hi, Daniel. Thanks for joining me today.
Absolutely. Thank you, George, for inviting me.
So I like to ask all my guests just at the beginning, where are you calling in from and what's the weather like?
Thanks. I'm in Northern California in Davis. Weather is pretty great. The sun is out and all the complexity wheels are spinning.
Yeah, well, that sounds like California. I did spend 6 years in California and I had a wonderful time, but having grown up on the East Coast, I just missed the seasons and kind of had to get back to the roots. But right now I'm in Colorado and having a bit of sunshine, so that's pretty nice too. So let's start. How did you get into complexity? What interested you that kind of led you into that field?
It's a great and obvious and challenging question. And I think, like many other people, even before I knew about the term complexity, I was wondering and curious about so many things and about systems. But the way it specifically came to be for me was through my PhD advisor, Professor Deborah Gordon, who was an affiliate professor at the Santa Fe Institute. And she recommended that I take the summer school in complexity at Santa Fe Institute, which I did in the beginning of my PhD in 2015. And leading up to that, in the year or two, I had read a few books, listened to a few things, but it was seeing it in person, connecting with those with more experience and seeing how it could be applied that also just opened my whole world and was one of those small changes that changed how complex systems unfold.
Change the trajectory of a human being, which is a pretty big deal. Yeah, that's great. So, so what was your PhD? What was your field of study?
So my PhD was in evolution and ecology, and specifically I was interested in the behavior of foraging of ant colonies. And so my advisor had a long-term field site in Arizona. And I was interested in continuing some of those experiments, understanding how ant colonies regulate foraging as conditions are changing and uncertain. And I was interested in approaching some of those questions using molecular genetics, like gene expression analysis, and also using neurophysiology, like measuring neurotransmitters in the brain and doing pharmacological manipulations.
All right, so you're already in a pretty complex area of study, and my own more surface understanding of the field is part of it does come out of the behavioral aspects of social insects. So it's kind of a core piece of the threads along the way of building complexity science. And one of my favorite authors, of course, you must know, is E.O. Wilson.
If I could just give a thought on why the eusocial insects are such darlings of complexity. First, they're approachable and accessible. They're on the ground. And so it's interesting that you say that they're like a complex system when also, like other complex systems, it's all in how one looks at it. Nothing could be cooler, but also more mysterious than understanding how the colony makes decisions that the nestmate cannot know. Like how much food is out there? How much food do we have? Is it going to rain? Those are things that we know are not happening on board the nestmate. And so it has long led people to think about multi-scale systems and systems that are in relationship with their environment, that construct their nest. So it offers us just a tremendous wealth of different ecologies that ants have adapted to all over the world. And it helps that when we abstract what they're doing, from a computational perspective, there have been many models that have been created, like for ant colony optimization or agent-based modeling with ants. So it sits right at the intersection of approachable, fun, awesome systems that everyone can love and find around them, with very intricate ecological questions and also some computational components that will entertain those who are interested in entertaining them.
Right, right. So it seems simple, but then it goes deep. I like the simple story about, gee, ants are not very intelligent creatures, and they behave in very much on the basis of their instincts or embedded programming, not anything where they're actually cogitating about big picture questions or anything. They're just following the tracks or pheromone trails or doing what they're supposed to do in the nests with an instinctive process at work as opposed to a cognitive process. And yet the operation of the colony itself is quite deliberate and quite intentional and has a whole lot of intelligence and decision making built into it. So it's an example to draw from ancient history. The whole of the colony is greater than the sum of the parts. The parts couldn't possibly contribute to that whole.
Right. One nestmate taken from the colony will pretty quickly die. And just like you mentioned, they're a total example of distributed and extended cognitive processes. And then one philosophical note that applies to systems other than ants. We often talk about like a nurse ant or a forager ant. So leaving the whole queen and royalty question for another day. Just focusing on the way that somebody will look at an ant out there on the pavement and say, that's a forager. And that's a lot like the way that we might observe somebody doing a behavior and then label them with, well, they're a firefighter or they're a teacher. And so it's kind of like this objectification and naming of the entity based upon what it was observed doing. And Professor Gordon has a 1992 paper on Wittgenstein and ant watching, where she talks about that space between observing the behavior and naming the behavior and then assigning that label to what it is that nestmate is. So it's one thing to say it is a forager, and you pull a step back, you go, well, I don't know who it is or what it is, but it is foraging. And there's even a space before that, before one has assessed what the behavior is, before they even name it as foraging. And it's actually in that relational and observational space that complexity just surrounds us.
Right, right. And it just raises some simple questions like, we know that human beings are different, and different animals are different. They have personalities. And are ants born to be in their particular roles, or do they share? Well, obviously they come from the queen, so they share genetic material. Is it a developmental process within the development of the individual ants that they get tracked in some triggering way by the environment or by the individual ants that are actually looking over the hive? I mean, that sounds like a mystery to me.
These are exactly the mysteries. It's another reason why it's a fun area, is the questions that are almost immediately apparent. Again, like, how do colonies make good decisions? And we observe nestmates doing different things. How do they come to differ in their behavior? And in fact, we observe different colonies of the same species at the same field site doing different things in response to the same environmental conditions. So what are the causes and the consequences of behavioral differences within a colony, amongst nestmates, and amongst colonies within the same field site, for example? And it's complex, but we do know a few pieces of it. And so, of course, again, another day when we dive into the ant biology, but even just framing it as a question of nested systems, quite literally in a nest, but nested systems that are enclosing one another and interacting systems, that's how so many complex systems are, with vertical nesting or hierarchical nesting, as well as a lateral interactive or collective behavioral component. Again, it's like a sharpening block for us to think about collective behavior with the ants, and then we also get to be there in the field looking at how they do it.
So I'm interested in kind of getting a picture of what it's like out in the field. I mean, you hear stories about people spending ridiculous amounts of time in strange postures. I could just sort of imagine you have to have microscopes or observing devices, or you can't put sensors on the back of the ants, right?
We were able to collect ants and chill them on ice and paint them, and others put QR codes on their backs and return them to the colony. So yes, sometimes we do mark, other times we're observing unmarked ants looking at like bulk flow. It's an example of applied logistical complexity to figure out how to get everything that was needed down there to Arizona, including dry ice, liquid nitrogen, and how to have something that might have been done in the context of a laboratory where we could control so many of the aspects and try to implement that in the field. And people talk about in the field like in real life, and so this actually was a field. What is it like to do field work? Well, I only know my own field site and experience, but I really appreciated and enjoyed the rhythmic aspects that it brought into my years. So for 5 years, to be able to visit for a month or two per year and have prolonged work where even when my thoughts were racing or I felt unsure about so many things, I knew that in that moment, I just need to drive safely to the field site. And then I'm going to get out the stopwatch and we're going to do this many replicates of this many seconds of just observing ants crossing this line. And then I'm going to go home and then there'll be some food. And so it provided an embodied structure and the opportunity to do some problem solving in some areas that I wouldn't have gotten access to in just a molecular genetics lab. Like, what do you do with a flat tire on a country road in southern Arizona?
Yeah, a new skill. It strikes me that this really makes clear that the work that you're doing in the complexity research related to ants, for example, really depends upon a lot of developments that science has brought to the table over a lot of years before. So, what are some of the other pieces? It sounds like you have equipment that reflects the high levels of engineering talent and skill and knowledges that have been built over generations. So there's a high level of engineering capability, and what else do you have to have with you to be able to do this work?
Sometimes it did feel like a high-low synthesis because we'd be out there with toothpicks or with wires or all these sort of improvised implements that those who do field work of any kind recognize it's what has to get the job done in the moment. And then to pick up the ants with this improvised ants capturing device and then drop it into liquid nitrogen and then be able to carry that back to our laboratory at Stanford in California and then engage in the pipeline of molecular genetics and gene expression analysis, it was always a fun contrast. And one way in which the technology that one area pioneers ends up having connections to a different field is like the fruit fly has long been a genetic study system. And so it was the first insect with a sequenced genome, and it's the species that has the most gene expression data sets. Now, ant genomics, the first genome was only available in about 2011, but already there's more than 100 ant genomes. And one can imagine that as the cost of sequencing and the availability continues to favor PhD students and others, the number of ant genomes is going to continue to rise up. So all of a sudden...
that's interesting that the ant genome is now 10 years ago. So there's a history of 10 years. And what's the name for Drosophilus? Is that the name of the fruit fly
Yeah.
that is so important in studies? Now that genome probably goes back at most 20 or 30 years.
Yes.
But as an experimental subject, Drosophilus has been around for probably a long time, maybe 100 years or
Yes.
longer. So that was something that was looked at with older techniques and older technology, and yet here now we have, many years later, we're using some of that knowledge, but building it in with new tools.
And in the lab meetings and in the discussions we have in ant labs, it's like one of our feet will be in lower tech ant papers, like a cool natural history observation or a fascinating mysterious behavior or just a piece of like species specific biology that's like, whoa, this ant species does such an interesting thing. And then the other foot is in these high throughput, massive scale, a lot of machine learning and genomics in the fruit fly. And we think like we're kind of connecting these pieces because some of these methods that take $100,000 or $1 million today, maybe it's 100 or 1,000 times more accessible in 5 years. So a PhD student who's just starting their journey, maybe when they're finishing, they'll see opportunities that they don't even exist today. And so that's part of this endless treadmill and recombining and development and cross-fertilization that's so at home with complexity.
Right, and you point out a couple of other technologies there, like computer technology. So you have the stuff that comes into the field and the instrumentation, that stuff, but then the data analysis that comes along, and the computer techniques that you're using today aren't simply like, when I got started, it was like spreadsheets and word processing, and that was it. Now we've got there's deep machine learning that takes huge masses of data. Just the whole process of developing the genomic data and being able to analyze it and put it in pieces. That's all brand new, right?
Yes.
Yeah. So it's interesting that there's an example, the thread from the past that depends on the work of the past that builds to where we are today, and then you've got new technologies, new discoveries, new ways of analyzing things, thinking about things that's brand new, and that's seems to be accelerating, as you point out. When a PhD student starts on their journey and where they end up, there may be new tools and techniques already. So it's a really fast changing area.
Yes.
And also, it sounds like it crosses boundaries. I mean, we've been talking about entomology as a field of study, but it sounds like that field of study now embraces a whole lot of other things. Not just the biology of action of the insects, right?
When I give a presentation, there's a few common directions that an audience member will take it. Sometimes, even though it's a scientific presentation, they'll take it to their own life and they'll talk about some ants they saw just 2 days ago, or they'll ask a question that they've been wondering about since childhood. So there's like a personal engagement when we open the door to complexity. And the other piece that often comes into play, and I guess it's always sort of a backhanded or a bittersweet compliment. It's like the person doesn't ask about the experiments or the conclusions that I actually carried out, but they'll talk about, well, what do ant traffic strategies teach us about cities? Or what can we learn about resource allocation in this other system? And so it's like immediately, just through a key word or a key term, it's like a nexus that this person has put one foot on what they just heard, and now they're bridging it to something else.
Yeah.
Because
So that has to be hilarious. The idea that there are traffic jams in ant colonies, right? And there are logistical issues in ant colonies, and that's just like cities. They are a city.
And it's not the ant research that I've carried out, but it's an example of just other fascinating ant research. They've looked at how in human escape situations, like escaping
Evacuation.
from a crowded, yes, evacuation on foot or in cars. What can be dangerous is when there's a liquid flow to solid transition. So the pressure increases, everyone's trying to run or everyone's trying to escape, and then it jams like a solid.
Right.
And
I've heard that referred to as a jamaton when it's on the freeways, but it's also a phase transition like water turning to ice under circumstances. And wasn't there a pretty horrendous episode was it in Houston at a concert a couple of years ago?
yes, phase transitions can be deadly.
Yeah. Yeah.
So
It's
the
just
human,
that crowd got to a certain point where it went from flowing to rigid, and then there were waves, like an ocean with waves started that kind of moved along and ended up crushing some individuals.
so problem, inspiration, possible applied complexity solution. People have researched under how high pressure, so to speak, the ants engage in actually a liquid to glass transition. And so even under higher density, they continue to flow in kind of this semi-fluid way. And then we can use the complexity idea of phase transitions, which I'm sure presents with 100 mathematical and formal rabbit holes. Knowing that some people study it from that way, we can just pull back to thinking, well, what would it be like to take advantage of the affordances that cities have today, like long-range communication or people who can have a view from the top, and engineer systems or simple rules or environmental contexts where that traffic jam or that escape is a liquid to glass, safe transition rather than a liquid to solid that might fracture.
All right, well, tell me again what liquid to glass means.
That's a great question. These are
I
all
understand liquid to solid. I'm not sure what glass is. Glass is a type of solid that shatters, but it's got a different crystalline arrangement. So tell me what that means in an ant colony.
there's probably many angles on what a glass is. Maybe it's just like the gray zone between a solid and a liquid, but it's a format. It's a pattern of interactions amongst subunits, whether they're atomic subunits in your window pane, or whether it's actually active subunits like ant nestmates that are navigating around. And the glass has a density that is akin to a solid, and there's limited mobility in how the subunits are passing by each other. And so it has some flow characteristics that are like a liquid, but also it can hold its shape, but not in a perfect crystal ordered way like a traditional solid might.
Right. So one way for the layperson to envision it is that it's plastic. It's got some flexibility to it, although it's sort of like a solid. And I guess I've seen in old glass, like in old colonial buildings back east, you see the glass will have floated a little bit over the centuries. It's a different time scale, obviously, than the time scale at which glass shatters. But and I did read about that episode, and I don't know if it was Houston or not, but they later analyzed and said, yeah, there are specific physical devices that could be installed in those situations that would dampen the flow and allow people to keep in a more fluid movement rather than in those crushing type situations. So, yeah. And we learned it from ants.
Partially. And I guess one other related phenomena in the ants is this like slower is faster. And that's one of the papers that was studying this phenomena. What is the simple rule that one could implement that would change how escapes work? And so not to just continue to hold on to this one example, but what are the simple rules that we can actually learn from and connect across different systems, where it's like, maybe when we're all driving on the freeway, if instead of the accelerate and brake, which causes like rippling traffic waves, what about if we all just agreed, like, you know what, 20 miles an hour will be just fine. So let's not try to thread the needle between 40 and then stop. What if we went slower, and paradoxically or not, we would all get there faster?
Right, and that's one of the arguments why traffic will get better with self-driving cars that are able to coordinate those things, as opposed to the independent agents of individuals sitting in cars. You'll have the cars as a network. That's fascinating.
And on the traffic, an example of an approach where it's like, we want to increase the flow of traffic, let's add another lane. But over multiple timescales, that might not change what one is wanting to change in the way they expect.
Right.
What if people go, I heard that freeway has a new lane, let's all take it at the same time. Or over the years, now another development has occurred where one can't keep on adding lanes, but there's increased flow. And so I think complexity happens in that qualitative and personal moment when we really start with a fresh perspective on, well, what are we trying to do? How are we going to do it? Who's going to be involved? How will we communicate it? It's all of those basic questions, basic not meaning simple or pejoratively, but basic, like the key foundational elements of an investigation or an application. It's in those spaces where, again, one is just surrounded by opportunities and complexity.
Yeah, so it strikes me again that complexity crosses boundaries of disciplines and fields. So it's got a horizontal complexity of itself because it goes into different fields. It threads across different fields. But even within a particular problem area, there are many, many different ways to assess it and look at it. So it's got a depth of the possibilities of how you look at it, and how you define the parameters, or how you structure the way you look at the problem is going to end up with different conclusions.
Complexity is broad. It covers many different systems, many different areas or disciplines, and it also can go deep. Like if somebody were to search for complexity phase transitions, they would find that that is indeed a deep rabbit hole. So if something is broad and deep, and that's even just a spatial metaphor, not the only one we might use, and each of us on our own epistemic knowledge foraging journey is only going to read the smallest subset of books, the smallest subset of listening experiences, meet just a few people in the grand scheme. How do we sense make with complexity and in complexity in light of that as our starting point, not our pessimistic ending point that we're not going to read every great book?
Right. I want to get to that topic. But before we do, I wanted to follow up on one of the areas that you're active in right now, and that's Active Inference, co-founder of the Active Inference Lab. And I don't know what Active Inference really is. I have the understanding of stimulus response and how you shape a response to the stimulus from the environment is an important factor in whether you survive or not. It's true for humans and it's true for other living things. And I'm also familiar with the concept of probability and making choices under uncertainty, and the idea that you'll make a guess and then you'll get evidence and you'll try and refine that guess and use essentially what's called Bayesian inference to come up with the best guesses you can under uncertainty. So that's the extent of my knowledge. So tell me about the roots of active inference and what that technique is doing.
Awesome. Great and fun question. Well, with active inference, the two key terms are right there in the title. It's about action, which is to say, like, whether physical action, motion in the world, movement of the body, or cognitive actions, which there's a whole other area, as well as inference, cognition and thinking. And it brings together action and perception and cognition into a common grounding. And it turns out that that common grounding, like some of these other areas we've been discussing, has a formal or a technical basis. But even at the qualitative layer, one can imagine first an action perception loop. So a given entity that's in feedback with their environment, physically and or informationally, and just start with the action perception loop and how to make good decisions and good cognitions amidst uncertainty. Oh, please unmute. Oh, wait, I cannot hear your question, George. Thank you.
Yeah,
but I'm able to take action to reduce my epistemic uncertainty. My Markov blanket was not receiving the sense states that I expected and preferred. I wanted to hear what you had to say. I preferred it. And then I was able to, without too much cognitive overhead, take action selection so that our communication can continue.
Right. So the 100 billion neurons in your brain were actively processing the inputs from the environment and the intentions which you had and which we had collectively, and so you were able to take action. I was going to say that a future guest on the podcast is going to be Gary Benjay, author of Unfettered Journey. It's a novel, but he weaves in there some philosophical principles, very interesting. And he actually has appendices where he deals with the deeper stuff. And one of the examples he uses is the simple worm. I guess it's referred to as C. elegans. And it has 302 neurons. And they've been able to model the neurons and how they help the worm make decisions to eat something, to stay quiet and digest something, to go searching for something, based upon the processing of the neurons. So, and actually, even with 302 neurons, it's a relatively complex process where he describes it as having sort of the lower level of perception with the relationship with the environment, and then a map of perceptions of the internal states, and then this map tries to find the solution that maximizes the organism's survival or thriving. So is that a sample of how active inference works?
It is. I'll give a few ways it connects. First, as you noted, complexity and subtle and nuanced behavior can arise even within a single cell. So C. elegans with the 302 neurons, as you mentioned, absolutely is capable of many cognitive behaviors like planning or as if planning, without going down the what is it like to be a nematode angle. And we can think about its nervous system and its body, its embodiment, its emwormment, as consisting of some functional components that are relaying in sensory information, like sensory inputs. It might be tactile, chemical, temperature, etc. And then that's what's entering into the organism from an informational perspective, like our retina or the recording device that we're speaking into. And then there's the aspects of the C. elegans that take action. So those might be the neurons that are then connected to like a contractile unit. So on the incoming, we consider those sensory with respect to cognition. And on the outgoing, those are like action messages that are being sent. And so that way of partitioning a given system of interest, which is the nematode in this situation, into internal states and external states that are intermediated by incoming sense states and outgoing action states, that is what people talk about as a blanket partitioning or a Markov blanket partitioning. And that is one of the core features of active inference, is this idea that that type of partitioning of things from other things and things from their niche and things inside of other things, something about that partitioning makes it excellent and very easy to compute on. Oh, please unmute again. Sorry.
Thank you, Daniel. That was quicker than the first time. So we're both learning. And I think I lost my train of thought about I think I was thinking about the process of taking input and then making a decision, and you can look at it at a very rudimentary level of stimulus and response, but now you've got a set of techniques or ways of modeling this thing that gets much more sophisticated, and you can program in a computer to model the kind of behaviors you're trying to understand or you're trying to see. So is that kind of what the lab, Active Inference Lab, is involved in?
If the process that you just described of a system of interest, either the real system or a simulation of it, that system engaging in perception, cognition, and action, that is cybernetics. If we can go there, then the Active Lab is a bit like the second order cybernetics, because we're interested in learning and applying and communicating active inference and being proactive about research debt, making sure that there isn't a bunch of incoherent and separated sense making around these ideas, which, although they can be communicated conversationally and informally, do have a tremendous technical depth. We're expecting and preferring the Active Lab to be a net benefit to our niche, to our informational niche. And
so it's a second order. Yeah, it's a second order. It's not just at the level of looking at C. elegans and modeling that, but it's a second order looking at those that are looking at and modeling and trying to find how the information can best be coordinated and flowing, and therefore make the most of that information.
Yes, and as individuals and as a lab, we're also engaged in the applying of active inference at the base layer. For example, thinking about personal level cognitive models, or how do we apply active inference to remote teams and projects and communities. And so with one foot in the practice area and one in the theory and learning, we kind of forge our way forward together.
So how would what you're looking at play in terms of figuring out human social dynamics? Just maybe follow a case or follow something which can explain that a little bit.
Sure. One difference between an active inference cognitive model and, for example, a reinforcement learning or reward learning model is that in active inference, the imperative is to reduce uncertainty about a preferred future rather than this open-ended maximization of a reward, which begets all of these questions like, well, then how do we value finding out new information? Or what will we do when the plan that we thought was going to be rewarding changes? And so the way that active inference can provide a new lens on everything from psychopathologies and abnormal psychology, or just neurodiversity more broadly, as well as human cultural and communicative behavior as a start, other than saying someone could search and find many recent examples, we can think about these kinds of actions that we take as not being fundamentally only in the game of maximizing reward of some fungible asset, basically points or money or social credibility or whatever it happens to be. And so by thinking about, well, what is the generative model of the entity? What is the cognitive model? What does that entity expect and prefer? What kinds of decisions are they making based upon their affordances their capacities for action, and how does incoming information influence their cognition with an action orientation? And maybe reward comes into that story, maybe it doesn't. And so there might be many behaviors that we can have a bigger perspective on when we relax the assumption that reward is being optimized and that's the imperative for every phoneme and word in sentence. It's just not plausible, and active inference helps meet us there.
Okay, it still sounds a bit of a mystery because you're talking about, if you talk about semantics, it's about the meaning, right? But if you talk about the structure of semantics, then you're talking about the meaning of the structure of the meanings, and that gets a little hard to wrap your head around. I mean, it's easy to understand stimulus and response. Okay, reward, incentives, that's easy to grasp. But now, if you're trying to construct something that looks, it sounds like maybe more towards aspirational or identity or belonging or, levels of achievement of the Maslow hierarchy that are unrelated to simple rewards. And so, it's like the pain pleasure principle. Boy, that one's easy to understand, but now we're talking about some stuff that's really a lot more sophisticated. But then again, we're dealing with organisms with 100 billion neurons, right?
100 billion or however many just inside the epithelia. But then when we take that extended, embedded, and cultured perspective on cognition, and it's like, is it just my or your 100 billion? Or is it actually this extended infrastructure that's supporting our capacity to have a remote conversation? And so that's where having the ability to model different kinds of cognitive systems and be clear about where our uncertainties are is just essential.
Yeah, so we've done a lot of offloading of cognitive functions to devices. We're using one to have this conversation. We're in two remote, places that, that was never possible in the past. And if you go far enough in the past, that is really, it was an interesting journey. I appreciate that. And I wanted to change gears a little bit, and it sounds like maybe there's some connections here that I wasn't really aware of. And that is, I know the other thing you're involved in, and which actually has been very helpful to me in trying to put this together, and that's the Complexity Weekend Community of Practice. And could you take a minute and just describe what that initiative is and when it got started? And then we'll go into what it's aiming for and trying to achieve.
Awesome. With Complexity Weekend, things kicked off in 2019, where my co-founder, Sean, and I co-organized a weekend event that was in downtown San Francisco. And that event had some facilitators and some presenters, a keynote speaker, and a bunch of participants who are all interested and excited about learning and applying complexity and doing it together and connecting with those who are complexity curious, whether they were just starting on their journey, just familiar only in the most superficial way, or those who had been learning and applying for a long time. And we had a great time in 2019. And then we thought, this will be awesome. We'll have such a great time building a local complexity community. Mic drop, record scratch, life-changing, etc. And so in 2020, we moved to being online and having a rhythm of online weekends and these shorter heartbeats that happen in between the weekends. And so we have had, at this point, speaking now in early April 2022, we've had 4 online weekend cohorts. And so that was 2 in 2020 and 2 in 21. And we're about 2 weeks away from the April 2022 weekend. And we can talk more about it, but just the short version of what happens at these weekends and in the spaces between and amongst the connections of participants is we come together, we have an energy peak, so to say, where there's a higher amount of synchronous activity whether just meeting and connecting with other participants or joining facilitated sessions, which are just on a tremendous diversity of topics and with facilitators and participants from all over the world. And so that is how the stage is set, with complexity curious participants from all over the world and many different stages in their complexity journey.
Yeah. So it's not just about getting together and having a good time and learning something from some other colleagues, right? I think there seems to be a philosophy behind how you are structuring this process. And am I correct? Do you have some thoughts about the overarching philosophy that applies to the way it's structured?
I think I'm going to have to listen to future episodes of this very podcast to understand the implications of complexity for philosophy and for organizational design. But yes, absolutely, from the beginning, we have asked and tried to address what does it look like to think of Complexity Weekend as a complex system and to learn complexity by being literally in complexity. And so the ways that plays out is in our thinking about feedback loops and in the conversations that continue with participants, or in participatory co-organization, for example, where any participant is welcome to co-organize an event as an absolute co-equal with us, or to have a participant step up into being a facilitator and then not give a 45-minute lecture, not to give a talk, not to send some transmission or special knowledge that they have to other participants, but even just to bring an intention or several questions, which many of the facilitated sessions happen to be. And so, yes, we, if one could call that a philosophy, hope to imbue complexity through not just what we did, but how we did it, how we communicated it, how we included people in that process. Okay, third time's the charm.
Yeah, I have a little congestion, so I'm turning the mic off and then forgetting to turn it on again. The idea is that, okay, you're pulling a collection of individuals together, some with different backgrounds. So it's like a colony is being established, and you're bringing principles in from complexity theory, like self-organization. So this is not a top-down hierarchical thing, like the way most conferences are. This is a self-organizing process where intelligent people are coming together. The rewards for them are friendship, fellowship, knowledge sharing, a sense of belonging. How does that now? It's working. You've got groups, right? So tell me where you hope it might lead to.
I'm tempted to even take the third order cybernetic option. I plead the third order. I hope it can unfold and expand into a changing world. So that would be what wakes me up and puts me to sleep with respect to Complexity Weekend. But to be a little bit more specific, I just hope that we can cultivate a space where, whether an individual is more interested in the learning aspects of the journey, learning about different terms and different key pieces of literature, or about different ideas and coming into a deeper personal learning relationship with the ideas, or and they're interested in applying complexity the way that modern professionals do, which is to say on these interdisciplinary and diverse teams. And so to be able to create a space where complex individuals and their relationships and their trios and their small groups and their fractal structure can just come together and complex out, and then also be scaffolded and supported with what their team needs from a logistical or from some other type of operational aspect, that would be something quite special.
Right. So its goal is to be generative, to generate ideas and thoughts and connections and to be generative, and also to be non-hierarchical, because it's clear hierarchies will control the flow of information. That's part of what they do. And when the human civilization went from a hunter-gatherer stage to agricultural stage, it had to invent hierarchies to manage information flow in ways that it never done before. Well, now we're looking at the human race 3.0 or 5.0, whatever it is, and needing desperately to find ways of better communicating among the 8 billion among us and sharing ideas and helping to shape things. And hierarchical processes don't necessarily facilitate that in a way that potentially self-organizing in collections of human beings, developing common aspirations, common motives, sharing of information, distributing information in efficient ways, as efficient as can be designed given what we know about complex systems and the efficiency of complex systems. So that's where you're hoping this is, and I'll echo that this is one of many similar. I mean, it's not the only kind of distributed system where people are working together, and we now have, by the way, the technology to enable that. Here we are.
And the yes and to that, which is always where the complexity is we cannot simply reject so-called hierarchical ordering. It cannot be the case that we do not provide any kind of scaffold, or whether we use a top and bottom, up, down, that's all spatial and in and out, it's all good. But to simply say that self-emergence is going to take care of it, especially in a world that's beset by so many ecological and social crises, is not a preferable affordance to take. Right. And so how to navigate this complexity of interpersonal relationships and communication and organizational design in a applied complexity community of practice where there is no top to impose from, yet we cannot be neutral with respect to many essential topics.
Right. That was a great review and introduction. Thank you. I wanted to shift gears a little bit because actually the title of the podcast is Making Sense of Complexity. And so I want to go to the making sense piece of this, and how have humans made sense of the bigness of the world and creation and all that stuff has often been through religion. And so I wanted to ask, do you have a particular religious background that you grew up with?
Yes, my religious background and inherited prior is Judaism, and that is where I began, and I continue on that and many paths.
And one of the features of Judaism that I'm familiar with, although that's not my tradition, is the one of inquiry, curiosity and inquiry and debate and discussion. So clearly that fits into a model of complex systems, right?
If I could give a thought on that, though I tend to try to listen and learn more on anything that's quasi-theological. During the Passover special dinner, the Seder, there is a ritual or a sub-ritual or a motif of the 4 children. And there are 4 archetypes or patterns of children who are engaged in different perception, cognition, and action at that Seder. So without going into details, which people can find, some children are more interested in the tactile or the sensory. Others are more interested in the intellectual or the abstract. Some children see how the events unfolding on the dinner table relate to them most personally, and others actually have a distance between what they are seeing and doing, and they ask, well, how does it apply to me? How do we make this an applied Seder? And so that is one of the inspirations for me when I think about, well, there's not just 4 and they're not just children, but there's so many flavors and threads and spirits that come through us as we're doing whatever it is that we do, which is just the complexity of before we name, and how do we recognize all backgrounds and preferences of those who want to learn and apply. And maybe somebody, you say, look, this is a tetrahedra, and it's like heavy and it's sharp and it's the minimal polygon that exists in 3D and it's like amazing. And then somebody else, all you had to do was tell them about the math. But somebody else might want to see how it's implemented in a building. And there cannot be simply a best answer or best way. It's even if it were rock, paper, scissors, there wouldn't be a best play. So isn't it a little bit more complex than that?
Yeah, and that's great. Three things pop into my head, and the first one is so these four archetypes that are represented in the Seder. I wasn't familiar with that particular aspect of the Seder, but those four archetypes are an embodiment or a cognitive embodiment of cultural wisdom that comes from thousands of years of observation and collective knowledge. So, there's a positive aspect to ancient cultural wisdom that we, ignoring it is not useful. And I like the way you characterize that then as a stepping stone for building additional wisdom on it. I've lost the other 2 points, but they were really good ones. So
more is always unsaid than said.
How do you feel your work in complex systems complexity theory how has that informed your the way you perceive and practice your religion?
It's a great question, and I almost would love to think and develop it more. It's the time and the place and the specifics of how I came through all of these cultural systems of religion and being in America and being in science that sometimes those partitions, I'm just not quite sure. I don't have the control group. I don't have the experiment with the person who wasn't exposed to complexity in 2015 or all of these other alternatives that in a classical scientific way would be able to give a clean conclusion. And that's like the complexity of our n=1 experience. So I don't know, but
right. So
maybe
there's a
in the
trajectory.
future we could talk more.
There's a trajectory. Each one of us has an individual trajectory that has shaped what we believe and how we view things. But the follow-up question to that is that something we can also choose to make changes in? And if we are thinking about making better, can we engage in inquiry about our own belief systems in order to make them better? I sort of answered the question, but I'll just let you respond to that concept.
Can we engage in inquiry to find out what we mean by better, and then how to choose what actions individuals or other levels of organization might take? Very important. Where would complexity be in that process? It would be the water that conversation happens in. It would be the glue when people are trying to connect disparate aspects of the conversation. It would be a shared jumping off point for two people who are in different time zones with different backgrounds. So I believe complexity could do many things in that conversation, even if ironically or paradoxically or in some way it wasn't in the final product. If the C word was not in the final product, it should surprise none who are familiar with complexity.
Yeah. And Daniel, last question that is, do you, there's a couple of ways to ask it, but one is, have you had experiences that, a personal experience maybe that has helped to reinforce this sense of the openness of the world that we're dealing with, maybe the caution about not making firm answers, but leaving things open, inquiring, or a sense of mystery or mysticism? That's a tough question, but I think you might have something.
The esoterica will be saved for another day, but what instantly came to mind was how a conversation amongst undergrads at a dinner potluck led to me meeting my wife and engaging on a life journey that couldn't have been comprehended even in the middle of our relationship, let alone at that doorway. And then in a little bit less of a romantic way, how conversations in a conference setting or in another way, like just following up with a paper I found exciting, led to just some of the most intellectually or epistemically thrilling experiences, but also hopefully some of the most impactful work that I've been able to be just one forager on. So I just think about how openness isn't always in the moment. We don't always see it as like opening a new vista or putting us into a different basin of attraction, literally in that moment. But then we look back on our trajectory and how could it have been otherwise?
Oh, God, I love that. It's like the possibility of this thing happening that happened was infinitesimally small. You'd say the probability was so small, and yet that now has changed my life in a profound way and given meaning to me in profound ways. You can't put necessarily labels on it. It's just that transcendent experience that as a result of that one little point in time. I've shared that experience myself, Daniel, and thank you for putting words around it. It was really beautifully done. So
if I could close,
yes,
if I could
please.
just close by linking a few pieces back together, it's that moment of choice in action, in the moment, about our next step, not where we'd like to be in 500 steps, but how we're actually going to choose our next step that the ant nestmate experiences as it decides to forage or not, whether it knows about what's happening inside and outside the colony. And it's something that we as cognitive foragers, as well as physical ones, engage in every day. And the question of connecting short-term action to long-term expectations and preferences is at the heart of active inference, and the ability to, in this moment, not at a future moment when we have more time, but in this moment, ask what people and tools and ideas can we include. That's complexity.
Daniel, thank you. This has been a true delight. I really appreciate the conversation, your support, your advice, and we are on a very interesting journey for sure.
It's the most memeable timeline. Wouldn't have wanted it any other way.
All right. Thank you. Thanks for joining us on this episode of Making Sense of Complexity. Next episode, I'll be joined by Daniel Sanderson, a writer and active blogger on science and philosophy, and the founder of Planksip, a philosophy and cultural media outlet for nonfiction authors and academics. In the meantime, please explore the websites of our collaborators, Complexity Weekend, Planksip, and Talk of Today, and join the conversation on our social media outlets or on spiralinquiry.org. Stay well and have a great week.